Hi and Assalamualaikum. My name is Ishma binti Fauzi. I will present to you introduction for this experiment. For your information, microorganisms require certain basic nutrients for growth and maintenance of metabolic function. Culture media, also known as growth media, are specific mixtures of nutrients and other substances that support the growth of microorganisms such as bacteria and fungi. Culture media are most commonly made from natural broth, which is frequently mixed with agar and prepared in petri dishes. To ensure that microbiological growth is properly promoted, culture media preparation must be done meticulously. Individual culture media ingredients such as powders, gels and liquids must be weighed out carefully according to the culture media formulation recipe. A closed culture media has no additional nutrients added to the system and waste products are not removed. Open culture is a continuous culture where periodically some of the bacteria culture is removed and added to a fresh sterile medium. Objective of this experiment is set up experiment accurately following the instruction provided. After that, observe and record the changes on microbial growth regularly. Furthermore, compare growth of microbes on different samples. Moreover, analyze the results and critically discuss the findings from experiment using knowledge in microbiology. Lastly, give a conclusion to the overall analysis.
Assalamualaikum and hi. For this part, I am going to talk about the experiment setup. First, for the 2.1, for the microbial grow on food, we prepare 2 rice, bread, biscuit, milk, butter, 10 plastic container and a thermometer. Firstly, all the plastic container have been confirmed to be clean and dry. Each container and scrap paper has been labeled with the name of the sample and the date of the experiment using the permanent marker. For the group A, it was a closed system. Each sample has been placed in the respective plastic container. The container lid has been properly assembled to provide a closed system. But for the group B, it was an open system. One set of each sample has been placed on the scrap paper or in the container for the milk and the butter. All samples have been left uncovered to provide an open system. Next, we go for the potato dextrose agar. First, we need to do a preparation of potato extract. Approximately 2 grams of potato has been washed, remove the dirt thoroughly, peel off the skin and cut it in dice. 250 ml of water was added and has been boiled for 30 minutes until the potato is soft and the potato infusion has been let to cool down. When the potato infusion has been let to cool down, the extract has been collected by sieving through a clean hot sieve. The amount of potato extract collected has been measured and adjusted to 250 ml with water. So, we continue to the preparation of the media. Tartaric acid solution was prepared by heating 50 ml of water to simmer and then 5 grams of tartaric acid powder was added and mixed to dissolve. The solution was left aside for later. In another pot, the potato extract has been reboiled and add 5 grams of sugar until dissolved and then 5 grams of gelatin powder. To prevent the agar from sinking at the bottom and burn, the mixture has been stirred continuously until dissolved. The solution was let to simmer and tartaric acid solution that has been prepared was added, and to avoid the solution to solidify too fast, it has been mixing continuously. The hot media was transferred into stir pantry dishes and was closed immediately. This step has been used by aseptic technique. For the nutrient agar, 50 ml of water was heated to simmer to prepare tartaric acid. 5 grams of tartaric acid powder was added and mixed until dissolved and leave it aside. 250 ml of water has been boiled in another container and 0.75 grams of beef stock was dissolved. Adding 1 gram of salt and 5 grams of gelatin powder has been dissolved into the mixture. The mixture has been stirred to prevent the agar from sinking at the bottom and burn. The tartaric solution that prepared earlier has been added into the mixture and the hot media was carefully transferred into the sterile pantry dish and was immediately closed using the aseptic technique. Next, for the media cultivation, firstly, we need a surface situation of working bench. A workbench in the area where there is no less traffic in the house has been chosen. Adequate amount of alcohol-based sanitizer has been spread on the surface of the workbench. The alcohol has been wiped using the kitchen tissue paper. The candle has been lighted up on the working area and was left for about 5 minutes before starting the procedure for fungal cultivation. We go straight to the fungal cultivation. The candle flame has been placed close to us throughout the cultivation procedure and the face mask has been worn while working. PDA and the NA plate has been placed on the sterilized working area reasonably close to the flame. A hole has been made in the middle of the agar plate using aseptic technique. One NA plate has been placed upside down on the working area nearby the flame. The sharp-pointed knife has been sterilized by flaming on the flame of the candle. The plate that contained the agar medium has been placed on the flat working surface. The sterile blade was used to make a hole by cutting the agar in the center of the plate. The plate was closed immediately when finished by placing back the agar plate onto the lid nearby the flame. Step A until C was repeated for the rest of NA and PDA plates. Then we go to the prepare fungal inoculum. One container of food sample was taken. The sharp-pointed knife has been sterilized by flaming on the flame of the candle. The food sample container was carefully opened and the area where the fungal growth is visible was observed. The sterile blade was used to cut a piece of the food sample with fungal growth. The needle in the another hand was used to hold the food sample in place while cutting. The sample piece of food was removed using the sterile needle and was transferred into the hole on the NA plate. The plate was closed with its lid. Step D was repeated by removing the second piece of food sample using a sterile needle and transfer into the hole on PDA plate. Step A until E was repeated for the rest of food sample. For the sample that cannot be cut in a piece, such as milk, the sterile knife tip was used to collect a small amount of contaminated food sample and has been transferred into the hole of NA and PDA plate, respectively. All plates were then incubated in the dark at room temperature. The observation was recorded for 7 days at 24 hours interval. The petri dish lid wasn't opened during the observation.
Now, I will present the result of the whole experiment. Firstly is result of bread. On the first day of observation, we find that the bread is still in good condition. Nothing changed on both of open system and closed system. Then, the last day of observation, which is day 14, we find that the bread undergoes many changes in open system and closed system. In open system, the bread turned very dry and very hard. The picture shows the difference between day 1 and day 14 of bread. Second is result of milk. The milk did not undergo any change, still fresh, on the first day either in open system or closed system, but it undergoes significant change on day 14, where the milk becomes very dry in open system, while in closed system, milk becomes bad and has a sour smell. Here we can see the difference between day 1 and day 14 of the milk. Next is cracker. Cracker also do not undergo changes in either closed system or open system. On the day 14 experiment, no change observed in closed system. The color of cracker still same, while in the open system, the cracker remains soft and the color faded. So it is the difference of first and last day experiment of the cracker. For the butter, no change observed on the first day in the both systems. The butter remains unchanged after 14 days in closed system, while in open system, the color of butter becomes brighter and still has no smell. Lastly, the result of rice. As usual, no change occurred on the first day of observation. On the day 14, we find that rice is completely covered by filamentous, which is white and greenish-black microbes in closed system. Rice in open system become dry and have black spots on the surface of rice. In day 14, we can see that the fungi completely cover the rice surface area. This table shows the result of the train agar experiment on the day 7. All source of inoculation has changed, which is black spot grow bigger. We can see that all the fungi completely cover on the surface of the sample. The second table shows the result of potato dextrose agar experiment on the day 7. The bread, butter, milk, and cracker grow a small of mold, while rice grew the bigger mold. We can see that fungi grow on a small scale at all food samples except rice.
Hello and Assalamualaikum. My name is Muhammad Danish Mirza and I will present to you the discussion for this experiment. From the experiment, we can observe that the bread sample in the closed system had mold growing on it and the mold reproduced rapidly while the bread sample in the open system just became dry. This is because higher rates of moisture and the temperature were suitable for the molds to grow. Once a spore finds a piece of bread in a dark cool place where air does not circulate well, it sinks its little feet called hyphae into the space that make up the surface of bread. Molds spread rapidly, forming the mycelium or mold colony. The closed system also kept the rate of moisture, which meant the humidity rate on the container stayed the same in height, which was suitable for molds to grow while the open system does not. The simple milk in the open system was being exposed to air, which has greater air exposure, and more frequent movement of milk do correlate with pH decrease, which suggestive of bacterial growth leading to milk spoiling. This way, lactic acid bacteria such as Streptococcus sp and Lactobacillus sp can easily end up in the milk. This type of bacteria ferments lactose at room temperature and turns it into lactic acid. More acid means more hydrogen ions, a lower pH and a sour taste. A lower pH changes the structure of proteins like casein, which gives milk its whiteness, so it curdles into clumps called curds, while the leftover yellow liquid is called whey. Firstly, crackers are flat dry baked foods typically made with flour. Crackers have a lower water content than air, so water will diffuse into the unpackaged cracker and turn it soft if left exposed to the humidity of air in an open system. Crackers in the closed system, on the other hand, are not exposed to air humidity, thus maintaining its physical characteristics. Secondly, the low moisturity texture of crackers serves as an unfavorable environment for microbes to grow. That is why we cannot observe any microbial growth on both sample crackers in a closed and open system. Lastly, the oil comes from the food processing of the cracker that made it a little bit moisture. However, there are studies that say some pathogens like salmonella can survive on dry food such as crackers. The researchers found that not only can harmful bacteria survive in dry foods like cookies and cracker sandwiches, but they can also live for long periods of time. Next, the butter. The butter just has a little bit of change in the physical characteristics during the 14 days observation. The butter both in group A and B was assumed to be still audible, and the condition just changed to be a lot oily than the original condition at the start of the experiment. This is mainly because butter has a high fat content which contains more than 80% of fat and relatively low water content, making it less likely to support microbe growth on it and make the butter have a longer shelf life than most dairy products. As a conclusion, this shows that due to the high content of saturated fat, the butter was unlikely to grow a mold. The rice will not show as much changes on the first day in both closed and open system. When day 3 approached, there were already signs of microbial growth on both of the samples. From day 3 to day 14, there have been visible physical changes on the rice. An example of the bacteria present in the rice is Bacillus cereus. When a small spore is formed, it can eventually turn into bigger colonies around the food sample. In the closed system, the container has also been covered up by water vapor. The vapor shows that these microbes are undergoing a fermentation process, as the bacteria present are known to be anaerobic. A few factors that can affect the spoilage of rice are the surrounding temperature and also moisture. In the open system, however, the rice soon became dry over the timeline between day 3 to day 14. Moisture plays an important role in this case because as the rice undergoes fermentation, the vapor is released into the air. As the moisture in the rice slowly decreases, the rice eventually becomes dry and orange spots soon begin to form on the surface. Throughout the incubation time, we can observe that the nutrient agar or NA plates that cultivate the microbes from all food samples have more colonies grown on it compared to potato destroys agar or PDA plates, and almost all its area has been covered by numerous black spots. This is because NA medium is universally used as a general-purpose medium for the cultivation of a broad range of microbes from fungi like yeast and mold to common bacteria such as Streptococcus sp and Staphylococcus sp. However, for PDA plates, we can observe that it has less colonies grown on it and it has a smaller area covered by black spots compared to NA plates. The reason behind this is, unlike the NA medium, PDA medium is a selective media that is commonly used for the isolation and cultivation of a wide range of fungi such as yeast and molds. It contains chlorophenicol that acts as a selective agent to inhibit bacterial overgrowth of competing microorganisms from mixed specimens while still permitting the selective isolation of fungi. The nutritionally rich base from the potato infusion encourages mold sporulation and pigment production in certain dermatophytes, while dextrose supports the general growth of microorganisms. These are the reasons why there are not many colonies of microbes can be observed during the cultivation process for PDA plates compared to NA plates.
Hello, my name is Hasmitra and I'll be talking about the final part of the experiment, which is the conclusion. So after 14 days of observation, we have found out that out of the 5 samples, the 3 samples that spoil the fastest would be the milk, rice, and also the bread. A few factors that could lead into them spoiling the fastest would be high moisture, temperature, and also the usage of preservatives. When we're talking about moisture, a perfect example would be the rice. Cooked rice especially has a fair amount of moisture. Microbes would take this into favor and they could have the opportunity to form colonies and colonies of microbes, causing the rice to spoil very easily. Now, the second factor that I mentioned was the temperature. An example for this would be the milk. So as we all know, milk has to be refrigerated because that can slow down rapid bacterial growth. But in this experiment, we left it outside for around 14 days, which means there would be a huge difference in temperature. This would of course be a perfect time for microbes to begin growing on the milk itself. As for the next factor that I said, which is the preservatives, the bread does contain preservatives, but it is only enough for a certain amount of time, which is why if you looked closely, bread has an expiry date which is a week or two after you buy it, which is why they say it is safer to consume the bread within the expiry date, because the preservatives probably die down after the expiry date, which causes the mold to grow very easily. Meanwhile, the food that spoil the slowest or don't really show any physical changes would be both the butter and also the cracker. Now, if we're talking about butter, it contains at least 80% fat. The other 20% would be water, which is relatively low. Another thing that we must keep in mind is that butter would undergo a churning process. A churning process is a very main process for obtaining butter. And because of this process, the water molecules will be separated and surrounded by the fats. This would make it difficult for bacteria to penetrate through deep. Now, another factor that leads up to this two not showing any physical changes or any microbial growth would be the type of preservatives that they're using. These preservatives prevent microbial growth for a longer period of time compared to the bread. Another conclusion that we have drawn out is it is very easy to notice when food goes bad. It is not only with the presence of microbes that you notice a food goes bad, but also through the odors it lets out or the change in texture or color. Of course, very common examples with this experiment would be the milk, where it released a very sour smell, and if we're talking about texture, it turned into a curd. And as for the rice, in the open system it became dry and also really hard, and the color also turned into an orange yellowish color. So when consumers notice these changes in the food, it is important for them to dispose of them, because consuming them of course can lead to illnesses. One of the most common illness known when eating spoiled food would be food poisoning, or even worse, when left for too long in the open, the spores could easily spread around. The spores could easily spread around, which could mean that these microorganisms would be airborne, which is why we have to take good care when conducting the experiment.